Okay, welcome back everyone to a new session for Computer Science 2. Today's session is to review Chapter 9 in brief, just to make sure that we are all on the same page when it comes to pointers. So what you need to know for this chapter, Chapter 9, we need to know, so what is a pointer? The definition of a pointer in C++. You need to know how to get an address of a variable. You need to know the relationship between arrays and pointers. You also need to know how to initialize a pointer. What else? We need to know how to pass pointers to functions or between functions, so how to pass and return. You need to know dynamic memory allocation. We need to know about memory leaks and how to avoid them. So this is the general idea of this chapter. These are the topics that you need to know. If any of these topics that is in topic for you, you need to go and read the chapter. Otherwise, just follow this lecture and refresh your memory. So first things first, the definition of a pointer. You need to know that a pointer is a variable. It's a data type. Just like you have integers, double, float. What is a pointer? A pointer is a variable that carries memory addresses. So just like char variables carry chars, integer variables carry numbers, double data type carries decimal, pointers carry memory addresses. And memory addresses, at this point, you need to know that they are in hexadecimal values. So it would look like something like this. C, for example, A9B07C. Addresses in computers are base 16. So they go from 0 to 9, and then A, B, C, D, E, F. 16 values. So it's a set of 16 options or possibilities, and then they will reset every time we reach the end of the sequence, just like you have in base 10, which is the base that we humans use, which is 0 to 9. Every time we reach the end of the sequence, we're gonna start over and increment the most significant digit. Then we're gonna iterate all over again to the end of the sequence. Then we're gonna iterate the most significant digit and start over. Once we reach 99, for example, we're gonna add a most significant digit and then reset the rest. So in base 16, it's similar, where values go from 0 to F, and every time we reach the end of the sequence, we increment and reset. So again, what is a pointer? A pointer is a variable that carries memory addresses. You need to know A pointer is not a memory address. Memory addresses are one thing and pointers are a different thing. You can think of it as a van, right? Mailing van, and then you have a cargo in it. So memory addresses is the cargo and pointers are the van. Van is not a cargo. So memory addresses are not pointers. Pointers carry memory addresses. And just like a van can carry different cargoes, pointers can carry different memory address. It can carry one address at one point, then another address at a different point in code, and so on, so forth. So it's not constant, right? You can give it one value and then give it a different value and another value, etc. So what is a pointer? A pointer is a data type. It's a variable that carries memory addresses. Now we need to know how to get an address of a variable. In order to get an address of a variable, we need to use the ampersand character. So anytime I have a variable, if it's an int, then pointers that point to that variable must be of the type int pointers. You do not have the chance to have a double pointer that points to a character. If you need to point to a character, it has to be a pointer to characters. If you need to point to integers, it has to be integer pointers. So pointers need to carry their specific data types addresses. How do I get an address of a variable? I need to use the ampersand character, which looks like something like this. So let's go to the code. Let's say I have an integer called my integer. I'm gonna say my integer equals 10. At this point, when this code executes, the compiler will go and ask the operating system for 4 bytes of memory. My program is gonna tell the operating system, hey, do you have a free memory? I would like to allocate 4 bytes for this program, and I need to reference it by this name. So anytime in my program, I type this name, I'm referencing those allocated 4 bytes. Why 4 bytes? Because integers are of the data size 4 bytes. Characters are 1 byte, etc. Here, when I say my integer equals 10, I'm telling the operating system, you see those 4 bytes that you allocated for me, I need to put the value 10 in them. So if I go here, I'm gonna draw something like this. Imagine this is part of the memory. So the memory is too big. And then the memory goes, let's say, from 1, 0, A, F1. This is the starting address. And then I'm gonna jump 1 byte. I'm gonna say 10AF2. 1 byte. And then the address is 10AF3. Then I'm gonna jump another byte, another byte, another byte, another byte. So a bunch of bytes, and then the rest of the memory. So this would be 10AF4, F5, F6, F7, F8, F9, and then FA, FB, etc. So when I create this integer, when I say int my integer, my program is gonna go and ask the operating system for 4 bytes and ask it to allocate these 4 bytes for my integer. So now my integer in my program reference this block of memory. This block starts at the address F5. Sorry about this here, but it is F9. Let's fix it. So this is F9. Then when I told my program on the second line that my integer equals to 10, I told the operating system to go to this block of memory and put 10 in it. I told it I need 10 to be in this block of memory. So now this 10 lives in the address F5, in the address 10A F5. Then I would like to reference this variable by a pointer. The way to declare a pointer is to say I need of that same data type, which is an integer, and then asterisk, and then I'm gonna say it is my pointer. As a matter of fact, it is my integer pointer. When I execute this line, same for the first line, my program is gonna go to the operating system and say, hey, I need a block of memory that can be referenced using this name. So somewhere else in the memory, there are other 4 bytes that, let's say, live in the address 29FC3 and were allocated. Then I'm gonna grab the address of my integer and store it in my pointer, because my pointer is the van and the cargo is the address. And the way to do that, I can say my integer pointer equals ampersand my integer. So now when this line executes, I'm basically telling the compiler, you see this address, I need you to point at it. So now what's gonna be stored in this block, which is the pointer, is the address 10AF5. So now this pointer that lives in this address is carrying or storing this value in it. The value that it's carrying is 10AF5. So basically it's pointing to that address. So now anywhere in my code, I can use or access this pointer to grab the address of a different variable. For example, I can display it, and I can display my integer pointer as is, cout my integer. So in this line, I'm telling my program, you see this memory, I need you to display the value inside it. Similar fashion, I'm telling my program, you see this memory, I need you to display the value in it. So this will display the address of my integer. If I need to dereference this pointer, meaning using this pointer, I need to access the value, my integer, then I need to prefix it with ampersand. So my integer ampersand. When I do this statement, I'm basically telling the program, in this variable, there is an address. I need you to go to this address and display the value stored in that address, which in this case would be 10. So let me repeat it while we are looking at this. When I do the ampersand my int ptr, when I do this statement, I'm telling the program, inside my integer pointer, there is a value which is 10AF5. I need you to go to this address and display the value in it. So let me execute just so you see it on the screen. Here, I created my integer and I gave it a value. I created my integer pointer, and then I gave the address of my integer to my integer pointer. So now if I hover my mouse, you're gonna see that this integer lives in this address and is carrying 10. So display my integer, display my pointer, and then dereference my pointer and give me the value that this pointer is pointing to. So notice the value is 10. This pointer is carrying this value, and then if I go to this memory address and grab the value stored in this address, it would be 10, which is correct. So that's the idea behind pointers, and they are very useful because of course, here it's simple, you're only working with an integer, but most of the time you're gonna be working with large objects. So instead of carrying that large object around the program and passing it from two functions, you can just use a pointer to that memory address, and then you can just pass that pointer because a pointer is much lighter. It's only 4 bytes no matter what you're pointing to. If I go back to here I am pointing to 4 bytes of block, but it stores only the beginning. So whether this block is only 1 byte, like a character, or 2 bytes, like a short, or 4 bytes, like an integer, or 8 bytes, like a double, or 1 gigabyte, like some object or some large file, pointers will only store the beginning address. So instead of carrying those 1 gigabyte all around every time you need to use that variable, you just carry the address of that variable. So they are very useful. So this would be done, the relationship between arrays and pointers. You're gonna realize soon that arrays are actually pointers, but they are constant pointers. So an array is a character is a group of characters. So let's say within the memory, I have the array that is this. So this memory here, let's use a different color. So this memory here is allocated and is referenced only by the address. Let's say the address is 103FA5. When I declare an array and I give it a value, the name of the array itself is the address of the first character. The address of the first character is at the same time the beginning address of the entire block. And the fact that I have null terminate this array, that means if I pass this address to some function, that function is gonna know that it should start at this address and finish whenever it reaches a null. So if I give this array to a function and I say display it, it will know that, okay, I need to display this, then this, then this, then this, then this, then this. Oh, null pointer, okay, then stop. Null character, okay, then stop. You also know that indexes start from 0. 1, 2, 3, 4, 5, 6. So this here is size 7 because 0 to 6, 7 characters. If I tell my program I need you to dereference the address 10FA5, what would this display? This would display the value stored in this address, which is the K. If I tell my program to dereference 103FA5 plus 1, which address is this? This address is 103FA6, which is the letter H. I can tell it 103FA5 plus 4. In this case, it is 103FA9. Which one is the FA9? 5, 6, 7, 8, 9. So it's the letter I. So if I go back to my program, with that being said, I'm gonna declare an array int l my array of size 7, for example, equals something like this. Or maybe it will add the null for me, so it doesn't like it. Especially for aggregated. Yeah. Oh, int char. It might add the null for me. If I add it, will it like it? Okay, it doesn't like it, so it will add the null for me. Notice I can say for int I equals 0, I less than 7 in this case, I plus plus. I can say cout L my array at this I and L. This we all know that it would iterate, and on each iteration it will display whatever I. So at the first iteration it's L my array 0, then 1, then 2, then 3. And it will display the character at that the character at that index. This statement here is equivalent to saying I need you to dereference L my array plus I. Based on what I just showed you in the paint, the first iteration, this would be 0. And L my array as a name, it is the address of the first character, or the address of the beginning, the beginning address of this array. So here I'm telling it I need the beginning address plus 0 to be dereferenced. Then on the next iteration, I'm telling it I need the beginning address plus 1 to be dereferenced. So these two statements are basically the same. So arrays are pointers, but you didn't know. So this will display k, and then this will also display k. Here it is. We have this because I clicked enter. Again, this will display h. This will also display h. H. Again, a. Now I is 3, so the beginning address, notice where it starts, CD4 plus 3, and then I'm dereferencing it, just like we dereferenced a pointer earlier. So this is the relationship between an array and a pointer. If this is confusing or new to you, you have to go and read the chapter. The next topic that you need to know is, so this is done, how to initialize a pointer. The rule of thumb is to start your array whenever you start your pointer whenever you create a pointer by assigning it null PTR. Null PTR means this pointer is not pointing to anything. So this is declaring, then initializing. If I have a value in place, then I can say, just like earlier, this equals the address of my integer. At this point, I can see out the dereference of my pointer, which is 10. Then I might have another, my int 2 equals 20, and then I can say my ptr equals this time the address of my int 2. See out. So just like I can say my integer at this point equals to 100, just like I gave my integer an initial value and then I changed it during the program, I did the same with my pointer. I gave it some value, and then during my program, I gave it a different value. So that's legal. This is how you initialize in case you need to initialize. There are, of course, eventually more details, but session is just a brief for the main topics, the main concept. If you think that this is something that is a little confusing, even a little, you have to go um, and read the chapter. So how to pass pointers to functions just like any data type. With any data type, let's say I have a void that says display. If I need to display an integer, I need to tell this function that you receive the data type integer a, some value. I need to display a value. So if I need to display an integer, I need to specify that this function receives this data type and this is the name of it. If I need to pass a pointer, then I need to specify the data type of that pointer. For example, integer pointer, a value pointer. Then I can display either whatever the address stored in this pointer or the value integer stored in that address. So either the address or the value in that address. And now I can say L my integer equals 10, pointer L my ptr equals the address of L my integer, and then display and give it L my pointer. So now if I run, I'm gonna see the address and then the value. So this is the address and there's 10 in it. I can pass as many as I want to a function, just like other data types. You can also return pointers. So I can, once done, I can say return a value pointer. I can say, for example, a value pointer equals whatever plus equal, for example, or plus plus, right? I can increment and then return. Now that I returned, I can say int L my ptr2, for example, equals, and if I display this bad boy as is and the value stored in it, I'm gonna see that they are the same address but different value. So I passed it to the first function, it was 10 and this address, and then on the same address the value incremented, so it was returned from display and then main displayed it. You need to know dynamic memory allocation. For example, just like you learned about the variable dying in when the function finishes, I can dynamically allocate memory during runtime. So for example, let's say I need an array of integers. An array of integers, I can either specify int array and give it a fixed size, or using dynamic memory allocation, I can ask the user, out, how many values would you like? Cn L users or L size, for example. And L size in this case is an integer. And notice it's an integer, not a constant integer. Remember, in arrays, you have to have them as constant, and it has to happen at compilation time. With dynamic memory allocation, it can happen on the fly. So here I can say I need an integer pointer, my ptr equals new int of this size. So on runtime, not on compilation time, once I receive the size from the user, I can ask the operating system to allocate memory of this size and then give me the beginning address. Now from here, I can start accessing. I can say for int I equals 0, I less than whatever size, I plus plus. And on each iteration, I can say enter next value, enter next value, for example. Cn into L my ptr at this I. I can use this notation or the pointer notation, which is something like this. Dereference L my ptr plus I. These two statements are the same, just like we witnessed earlier. The problem, this solves a lot of issues with arrays having them, must have them as fixed size. This solves that issue that you don't have to have an array of fixed size at compilation time. You can just allocate memory on runtime. However, the problem with this approach is that you might, of course, ask the operating system for new memory, and the operating system doesn't have a new memory. Memory is full. That's one issue. Another issue is if your program keeps allocating memory without releasing that memory, at some point you're gonna eat up all the memory in the system and your system will crash. Now let me show you this before we start changing the code. At this point, I'm gonna just see out for you what happened. So run. How many values would you like? I would like one. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So on runtime, I asked the operating system for memory for 5 integers, and I received the beginning address of that block, and I populated it with values. Notice if I say I need my pointer up to 1 million, for example. I need to run this 1 million times. And I'm gonna send size 1000. So I'm gonna tell my program I need a pointer to 1000 integers, and I will start allocating blocks of memories 1 million times. So 1 million times 1000. Notice at some point, my program is gonna eat up all the memory, and we can watch it here, because Task Manager can show me how much memory this system is running. So performance, memory. So I'm gonna say I would like 1000. Now for 1 million times, I'm gonna be allocating 1000, 1000, 1000 on each iteration. So now notice, memory is gonna start growing. 1 million, 1 million, 1 million. So the point is, every time you call this operator, it's not releasing the old memory. It's building up. My pointer will always be pointing to 1000 only, but the previous 1000 did not get released back to the operating system. Here you're asking for memory, then you're asking for memory, then you're asking for new memory, always asking for new memory without giving back the old memory. So at some point, you're gonna eat all the memory. Eventually, my laptop is completely empty. I don't have anything on this laptop but the basic software. So if I keep this running for a while, maybe it finished. So it finished. Let's do more. Let's do 1 million. So 1 million times 1 million. Enter. So this should eat up all the memory at some point and crash my system. Because I didn't give back any of the allocated memory. So my program will eat all the memory available by the operating system. I see that it maxed out. At some point, it should crash. Here, probably the operating system is like working things out. You know, it knows that it's the same program and those memory are not used probably, but at some point it should crash. Hmm, strange. It took a while. Or maybe this is showing me part of the memory, not all of it. Interesting. Which eye are we on? We are on. See, it became very slow. 144. Wow, it's a long way. It's still a long way to go. Yeah, if you keep running this, it will crash. Oh, here it crashed. Bad allocation. So I hope you're okay. So as you saw, this would break your program. This would break your system. Excuse me. What we need to do is every time we allocate memory, we need to release it back to the operating system. This way, we don't allocate more than needed and we always free up the memory that we are using. So in this case, every time I want to allocate a new memory on my pointer, I need to delete the previous one. This wouldn't, oh, I didn't declare it yet. So let's declare it above and say it is null PTR. LPTR equals Z. So this wouldn't eat a lot of memory because every time I'm about to allocate a new memory, I'm releasing the previous one. This keyword delete as is for single variables. If I want to delete an array, I have to add the bracket operator. So briefly, if you have one integer, my integer equals 10, for example, and a pointer, my ptr equals new int. That's only one integer. I'm pointing to only one integer. Notice the difference. Here it's a new int 1, and here it's a new block of integers. So here I can say my ptr equals the address of my integer. Once I'm done with this pointer, I can then call delete my ptr. I'm deleting only one integer, only 4 bytes. However, if I'm declaring it with the new operator and the bracket means a collection of integers, then I need to delete it with the bracket operator. So delete versus delete bracket. This is everything you need to know for this chapter in this course. Let me know if you have any questions.